Okay, so I hope you have done these two practice problems here. The question was to write the same integral or to write the integral representing the same volume in the order dz dx dy and next in dx dy dz. All right. And so the way you think about this, remember, this is a solid. All right. So the first thing you have to ask is y goes from what to what? Okay, y goes from 0 to 5 as before, right? And then for each y, so what you can see is my blue triangle. Right? If you cross this or if you cut the solid at this one particular y, what the cross section looks like is, of course, a right triangle, right? And so you get this right triangle when you decide to pick a particular y between 0 and 5. And for that triangle, x goes from what to what? And the answer is from 0 to 5. It's that, okay, from 0 to 5. Ooh, that's that. Sorry, 0 to 6. That's it. So 0 to 6, okay, for each of these triangles, regardless of what y you picked. And then the third part is similar to what I showed you at the beginning. Then the question is, for each y and x you pick, z goes from what to what? And the answer is from 0 all the way to when you cross that, plane, which was the plane z is equal to negative 1/2 x plus 3 as before. Okay, so you put these things together, and the triple integral in the order dz dx dy is from 0 to 5, from 0 to 6, from 0 to negative 1/2 x plus 3, and then dz dx dy. All right, you can maybe do this as an extra practice. Go ahead and do this if you like. You will get 45 as your answer because that represents the same volume. All right, so that was kind of similar to the first illustration I gave. Look at the second illustration. This, I hope, is going to look significantly different, right? And the reason is because x comes before z, right? And if the order, see here, you can see z depended on x, right? But here, x must depend on z, so you have to sort of turn things around, okay? And hopefully you've seen this, having tried this problem here. So here's a solid question, all right? Uh, no pun intended. The solid question is, so first I have to decide what z goes from and to, right? Z goes from 0 to 3. That's the entire height of this block, right? So z goes from 0 to 3. And then for each z I pick, and maybe I should just mention this and then draw this at the same time. For each z you pick, oh, okay. For each z you pick, this is a solid. If you pick a particular z and cross this, cut the solid at that particular z, what you will get this time is a horizontal rectangle, right? Just like the one I just drew here in blue, okay? So once you decide on a particular z, you find out the cross section of that z value with the block is the horizontal rectangle. And for that horizontal rectangle, the question is, y goes from what to what? Obviously from 0 to 5 as before, so that part is easy, right? And then once you decide on the z value and the x value, the y value, what does x go from and to? X goes from this point to this point, from this point to this point, from 0 to whenever it hits this plane, right? Now remember, the plane had a side view like this one. All right, so z was 3 when x was 0, and x was 6 when z was 0. In the last two examples, I wrote z was equal to negative 1/2 x plus 3. But this time the question is, x goes to what based on z? So did you realize that you have to solve this for x? Right? So you go from here and then you solve this. This is a simple algebra problem. But if you solve this for x, you get x is equal to 6 minus 2z or negative 2z plus 6. Either way is okay. But this is the key thing you have to have in the upper bound for x, right? Because the question here is x goes from what to what? And so x goes from 0 to 6 minus 2z. And this is the correct answer for the integral that represents the volume of this prism triangular prism in the order dx, dy, dz. Notice here, this one looks very different from what you had before, okay? And that's because you switch the order of x and z. Again, you can practice on your own, and I'm showing you, you don't have to do this, but if you want to just continue and do a little extra integration problem, you can determine the value of this by simply doing your triple integral from the inside out and then get 45. Now, I do want to point out one thing here. You notice here, once you take this integral, okay, you get 6 minus 2z. And then if you take the second integral, like from here to here, you get this expression. And then, of course, you integrate with respect to z in the end. But at this point, you have this thing called 5 times the quantity 6 minus 2z. You know what that is? This is actually, remember, you have yet to integrate with respect to z. But that this whole expression is the area of this rectangular region that I am drawing in blue for a particular z value, okay? So for instance, when z is equal to 3, up there is no rectangle, because when z is equal to 3, then this part is 0. But if z is 0, then this will be 30, because at the very bottom you have a 5 by 6 rectangle, right? So this represents, okay, this part represents, the integrand at this point represents the area of the cross section of the solid with that particular z value. Knowing that, or having figured that out, then you integrate this with respect to z. So you're collecting, you know, the bunch of these rectangular regions from z going from 0 to 3, and that is, of course, a solid volume, which is 45, okay? And so I say this is sweeping along z from 0 to 3 to get your answer, and that's what's happening with this, right? And I think it's important for you to, you know, at least visualize what you're integrating, like in which direction, in which way are you sweeping? Remember the Lego example, you know, are you collecting it this way and this way, or the other way around? Well, this time you have 3 variables, so that makes it a little more exciting. Okay, so the next question has to do with what I call the Jeopardy-like question. So let me explain what I mean by that. Okay, so far I have given you a solid, and I drew it for you, and then I gave you a definite order, and then you were to set up an integral and to, you know, evaluate if necessary. This time I'm going to give you the answer. The answer is this, as Alex Trebek would say, and then he would say, now what is the question, right? And the question is what you have to find out, right? So if I said this is the answer to the question, the volume of the solid is this, can you find the volume? Can you figure out what the volume, what the solid looks like? Okay, this, in my opinion, is very important in demonstrating your understanding of multivariable integration, right? If you can go both ways, right, to set up integrals, and also to look at a triple integral and figure out or sketch the volume or sketch the solid of which the volume is given, right? That's a very, very important skill, and that will show you your understanding of the matter, right? So try to figure this out, all right? Let's do this together, and then I will have a couple more examples after this. All right, so the first thing you want to do is to go from the outside. Z goes from 0 to 4, right? And then for each z you pick, y goes from 0 to 1. And then for each z and y you pick, x goes from, not from 0, but 2y to 2, right? So this is the key part here we need to figure out, all right? And at this point, you may have some picture of what this is supposed to look like. You may have no understanding of what this looks like. That's okay. Either way, we are about to figure this out. So the first thing you want to do is to try to draw this on the XY plane, because X and Y are involved in this. Okay, the other ones are pretty simple, right? I mean, these are constants. So this part, well, okay, so both of these, X is equal to 2, that's an easy one. Right? X is equal to 2, right? Looks like this. And then this part here is X is equal to 2y. In other words, y is equal to 1/2 x. All right, you know this as the line that goes from 0, 0 to 2, 1. After all, the slope is negative 1, slope is 1/2, and the y-intercept is 0. Now notice here, this line is saying for each particular y you pick, x goes from this line, which is x is equal to 2i, right, to 2. Okay, so we are talking about this area, not this side here. This is not the area we're looking for, right? So this last equation or last inequality will give you, or I should say these last, the upper and lower bounds for x will give you this region. Now notice here, y goes from 0 to 1. We've got that because that's exactly what we drew here, right? And so now we just have to add the third dimension, which is z going from 0 to 4. All right, so let's try to make this into a nicer picture and then see what works. Okay, and I have a little secret, not really a secret because I'm telling you this, but I have a little strategy that may help you, right? Because we are not certain yet what it looks like, maybe it's easier to use a pencil or a very light colored pen or ink or something, right? So I have this this rectangle, I mean, sorry, the triangle, right, that I colored in red. So let's go ahead and try to do that. All right, so you have 1, 2, a 2 by 1. So it sort of looks like this, and it is not, it's actually this side, right? So here's my line, here's my line. I'm going to shade this now. Right, so the solid triangle that I came up with is actually this one. Hopefully you can see that. This is the line y is equal to 1/2 x, or x is equal to 2y, right? And so, and I just drew this along the floor, which is called, I mean, it's not floor, but it's the xy plane, right? Right. So this is, the picture I have is exactly what I came up with here. And then now I just add a new dimension. Notice here, y goes from 0 to 1, and x does go from 2i to 2, right, at every point. And now z goes from 0 to 4, so let's just add, 1, 2, 3, 4, and then straight up here, 1, 2, 3, 4, will give you this point here, like that. And then there's a triangle here as well, right? And this is going to be looking like this. And so this is the right triangle. I know it's hard to draw these things, right? And then of course the top is the same right triangle as the bottom, right? Now again, let's go back and check to make sure that we got the right solid here. Z goes from 0 to 4. Okay, does it? Yeah, it does. Okay, Z goes from 0 to 4. And every time you slice this at a particular Z value, let's go ahead and draw this. If you cross this at a particular Z value, you are going to get the same triangle or congruent triangle. Okay, it's a right triangle. And for that right triangle, y goes from 0 to 1, does it? Yeah, y goes actually from 0 to 1 because this is the thickest part of the triangle, and y goes from 0 to 1, right? For every one of those triangles, the horizontal triangle. And then once you pick that particular z and that particular y, x goes from this point to this point. And this point is on the line x is equal to 2y, and this is the point x is 2. So x goes from 2y to 2, which is exactly what this says. All right, so the answer is going to be this triangular prism of height 4. Okay, and that's what the this triple integral is representing the volume of. This requires a new type of thinking maybe, and this may be challenging to some of you. So you may want to practice this a bit, and I have given you a few examples in your homework to work on. And by the way, your homework in this section has, I think, only 5 problems from the my open math section, and I supplement it with 5 or 6 problems where you are to set up the integrals, and those are found in the textbook, right? And what I mean by that, it's the OpenStax book, volume 3 of calculus. So just for this particular section, you will have some problems to do from the book. Okay, just to make sure you know that. All right, so I'm just going to say one more thing and then do a couple of examples to finish this up. If you have, let's say you have some f of x, y, z, and you have the z dy dx, doesn't matter what order it is. Okay, so you need to know some things like what you should be expected to see and what you can't have and so on, right? So here, these two upper and lower bounds, okay, what can they have? Do they have to be constant? Or can they have variables? Yeah, you can, all right? So these can have, obviously you are going to integrate with respect to z, so you cannot have z, you know, in the upper or lower bounds, but you can have x and y. Okay. Now, once you do this integration, you're going to do this one. So these two can have what? You can have x, but not y, because you're already integrating with respect to y. And for these, they have to be constants, okay? Because at the end, I mean, after everything else, you're going to end up with a number, and so you can't, obviously, you can't have any variables. All right, so I'm going to give you two more practice problems, okay? So you can be fully ready to do your homework problems and your exam problems. All right, I'm going to ask you this Jeopardy-like question. The answer, the volume of this solid E is the integral from 0 to 4, -2 to 2, and y squared to 4 of dz dy dx. Okay, so I'm going to give you 30 seconds to answer this final Jeopardy question, and you are to sketch the solid for which this is the volume. All right, so when you're ready, and you can play that Jeopardy theme if you like. 30 seconds, doesn't have to be. When you think you're ready, you can come back and see my drawing, which is going to be the correct answer. That would describe the volume, describe the solid for which this is the volume. All right, so I will see you in the last section of this video lecture.